So today's topic, the title for second week, 3D visualization of design. Okay, 3D visualization of your design. In the class CAD and Graphics 2, today's topic, title, 3D visualization of design. So here I list what to do today. We will have the lecture, 3D visualization of design, and then we need to take some technical notes and some setup issues for accessing local area network, just what we did, and something more for rest of our lab exercises. In the lab exercise hours, we're gonna install 3D Studio Max 2015, okay? Some of your computers already got installed 3D Max design 2015, but some computers are not, so we're gonna do that first as first lab exercise, and we're gonna take a look at some SketchUp-based V-Ray rendering issues. Most of you already experienced what we did last year. Some of you are totally new to such kind of visualization and rendering, but I told you before, we will have 1 hour or 2 hours lecture first and then move on to the lab exercises. Fortunately, today's lab exercise, no mandatory submission required, okay? From next week, you're gonna get some assignments, mandatory submissions within the classroom, but today, just lecture and some lab exercises in some casual way as a review. And we have to get prepared rest of classes, such as installing 3D Max and take a look at interface of 3D Max design. So we reviewed how to access the main computer for accessing network so that you can get the files, this kind of slide files and lab exercise files. We're gonna deal with that part in lab exercise hours. Let's move on to the course material. Okay, first question is, what is the essence of design? We are in the Department of Interior Architecture Design. Simply say, design department. So you are mostly second year student. As a second year student, can you answer me what is the essence of design? What's the design? Can you distinguish your interior architecture design, architectural design from other types of design? That's my first question. 이상호. Okay, what is design? The term design here means interior architecture design or architectural design. How to differentiate that design from others? Okay, human life, human scale. Okay, any other designs for non-human?
Very basic human live in space.
Okay, we are living in a specific building. Now we are in a specific building, College of Human Ecology building, 5th floor, 504 computer lab, right? For the classroom, in this classroom. Okay, we can distinguish our design, our major topic of design going to be kind of human-oriented, something like that. Okay, good approach and one of the good answers. But actually, my point here is we need to define design explicitly, not implicitly, okay? Human-oriented, very good phrase, but actually it's ambiguous. It's not total, understandable, normal definition. What I mean is when you are designing environment in your design studio, you can talk anything. You can express your design concept in higher level, but when we are using computers, the scope of design and the definition of design supposed to be something lower level. Lower level means something explicit, okay? So there is no specific definition. There is no such definitions in the term, in the taxonomy of design. But what I want to show you today is some brief, very, very brief history and one of the definitions in design, especially focusing on computer-aided design and design computing that we are dealing with in the classroom, okay? So I like to show you a brief history of architectural design. Architectural design versus construction. Actually, we are not dealing with construction so far, but in the future you have to, but not in this classroom. Anyway, our focus is on architectural design, especially interior architecture design. But let's compare design versus construction. "2,000 years ago, there is very famous man named Vitruvius, okay, 2,000 years ago. Vitruvius wrote one of the famous textbooks in architecture domain named 10 Books on Architecture. 10 Books on Architecture, that is kind of very old and very famous architectural book. I'm not talking about his life or his achievements. I would like to bring your attention. He is the first man who kind of invent plans, elevations, perspectives, sections, and so on, drafting. So you know what is floor plans, what is elevation, what are perspectives, right? Around 2,000 years ago, Vitruvius invented that kind of concept for designing building. He's the first man to introduce that kind of approach for our building design. And also he is believed as the first architect in human history, okay? Secondly, in Renaissance period, there was a man who named Leon Battista Alberti. He's also very famous. Around 400 years ago, okay? Oh, actually, I'm not talking about his life or his achievements too. I would like to put an emphasis on he's the man who distinguished architectural design from construction, okay? Now there is design job, designers, and there is construction job, construction companies, construction experts, and there are architects and designers, totally thanks to his distinguished approaches to design and construction, okay? Before him, before Renaissance, before Alberti, design, construction, they all in between, all combined. Someone who's in charge of making building, he's in charge of design and construction, okay? But he distinguished architectural design from construction based on Vitruvius' approach, okay? He reviewed this book, 10 Books on Architecture, and he wrote this book, Leon Battista Alberti's Architecture, 10 Books. The left one, that image drawn by Leonardo da Vinci, that is very famous, something about human scale. The title of that book is Vitruvian Man, kind of homage to Vitruvius, drawn by da Vinci. Anyway, 400 years ago, we just got separated, design and construction, okay, in architecture domain. Around 100 years ago, in modern architecture, 100 years ago, there was very famous phrase, form follows function, which means very representative catchphrase about modernism, okay, modern architecture. Every building in box shape, very effective and very non-decorative, very functional, okay. Coined by Louis Sullivan. He's also referring to Vitruvius, okay, who believed that plans, elevations, perspectives, that kind of draftings, that kind of architectural drawings are building design, okay. He believed design can be represented by such drawings. Okay. Even 100 years ago, one big difference from contemporary architecture nowadays, there was no computers, okay? Only 50, 60 years ago, human invented computers, and around 30, 40 years, we have been using computers for design. Compared to 2,000 years, 400 years, 100 years, no computers, all hand-drawn, hand-drawing, hand-drafting things. But contemporary architecture, we know there is 2D CAD, also known as computer-aided architectural design, computer-aided design and drafting, even 3D graphics, this class, okay? But actually, something cutting edge, something, the most advanced CAD system so far is so-called BIM, Building Information Modeling, okay? But in this semester, in this class, we are not going to deal with BIM, but you're supposed to know the concept and approach in terms of its history, okay? We have been using computers only since 70s. That means just 40 years ago. And now you got trained computer hardware and software just 1.5 years, okay? So in your design studio, almost all the time you are using computers for your design development, concept development, design presentation, and so on, visualization. So we need to know the entire process, where we should go, and you have to know where we are, okay? That's my point for today's lecture. Before getting into that detailed issues, I like to bring your attention again, what is design? Actually, I introduced you this one before. What is design? Actually, there could be amount of different definitions and descriptions, but I would like to show you this approach. Defined by Chuck Eastman and his colleagues, Georgia Tech. Someone who's studying, researching in design computing area. So this is design computing class, computer CAD and graphics class. So I would like to show you one of the definitions about design in their perspective, in design computing perspective. Very explicit and easy to understand. Structured arrangement of design units, structured arrangement of design elements. Very simple definition about design, building design. So what are design units? Number one, physical element that forms a design. In other words, anything else in physical, touchable, tangible. For example, we can touch walls, windows, curtain wall system, ceiling, floor, object, and something else, furniture. Everything can be filled with in our space, okay? Physical element. Of course, physical elements are very important thing when you are designing, okay? Second one, what is that? An element of design that a designer can cognitively deal with. Cognitive deal with means something physical, including something virtual. Okay, how about this one? Design process. Design process is not a physical thing, it's conceptual thing. Design from A to B to C, D, something like that. Process is conceptual, but very important in design process for your physical elements. Anyway, that kind of untouchable, not tangible elements units are also very important design units, what you should deal with. So structured arrangement means make some deployment, how to assemble them, how to make something new from existing scattered components, elements. The process or entire mechanism in that definition is simply say the term design. What is designing? Designing is an act of creating and elaborating a design, okay? Plus some time axis, time period. In other words, focusing on process, okay? So by using computers, we're gonna make some physical element. That is why you have to design floor, walls, ceiling first, so that you can create interior space first, and map material and place furniture, insert ceiling, lighting objects, plants, sometimes human beings, and try to make it some visualization, physical elements. That process, something plan, something invisible, something not touchable, such as lightings. Lighting objects are visible and physical, but lighting photon system is not visible. But thanks to that lighting, we can see objects, okay? That kind of thing can cognitive deal with also component of design units. Very explicit and straightforward definition about design. So you have to take care of this definition when you are designing using computer software for your design. Okay, let's talk about some approaches. Okay, now we know what's design, something physical and something virtual. So what you need to do? First thing is making something, visualize something, okay? This is geometry-oriented approach to the design. Okay, there is a box. There is a box. For making this box, continuously we need to define vertices and their connections, edges, faces, polygons, and make them one single cube component, so using enclosed surfaces. So we can get this box, okay? In terms of computation, in other words, in terms of arithmetic mathematics, arithmetic calculation, this single box has very complicated foundation in terms of its geometric definition. It's not simple. Computer can understand this box based upon series of additional components definition, okay? Actually, conventionally, CAD systems only deal with this kind of geometry, okay? Because geometry is almost everything, because we can see it, okay? This is geometry-oriented approach to the design. Simply because people believe that geometric shape is all about design. Okay, if you are a box designer, you have to design something like this, okay? Some alternatives of this shape. Alternative A, alternative B, alternative C. Anyway, all are kind of visible box shape like that. So formally, we believe that this kind of geometric shape is almost everything about design. But actually, geometry is just one part of design, just a subset of design, not everything, okay? Simply compare to other design domain. What if a game designer? What if there is a product designer? You are designing architectural environment, especially interior architecture. Okay, this is very important for making wall object, floor object, and lighting structure, and so on. But for game designers, same geometry, same box, same flat, same plane, same cube. Product designers, even cell phone designers, they use same geometry, okay? This is very important and fundamental approach, but not very compatible to architectural designers. In other words, not 100% for architects, okay? That's just one part of generic designers approach. I mean, geometry-oriented approaches. So what kind of different approaches we need? This is one example. I would like to show you a little bit different standpoint. But actually, I said different, but actually you already know what it is. Building object-oriented approach to the design as a building designer, okay? So we can break down our structure. We can break down our subject. Our subject is building, especially building interior, furniture, whatever. I mean, design elements which form a building. So that is conceptual modeling of a building. We have site, okay? Site. So, for example, we have Hanyang University site, and there are more than 100 of buildings. So one site has one or many buildings, okay? One building has one or many floors, okay? This building has 8 stories, 8 floors, okay? So the notation here means one building has one or many floors. One floor, this 5th floor has one or more space objects, okay? Including this room, okay? This 5th floor has 15, 20 spaces, including toilets and corridor area and so on. And also one single space can be, one or many spaces can be grouped by specific space group. For example, in this floor, there are a couple of buildings. We can assign the name, Department of Interior Architecture Design. Elevator room, toilet is not contained by that space group in interior architecture design. That is building common space. And common lecture room is not our department area. But this space is for interior architecture design department, something like that. Space group, okay? And also there are amounts of interior facilities, including tables, chairs, interior finish, floor material, and so on. So we are dealing with in this structure, okay? In terms of information, not just geometry. Okay, after defining this structure, and then we can define the geometry for interior facilities, lighting systems, for a specific building space, for specific group of floors, and for building, and so on. That is conceptual modeling. Geometry is one part of information. Let me show you a bit more elaborated model using the same approach. Also, we have a bunch of more structure. All these relationship shows you spatial containment. Spatial containment. But of course, there are amount of physical elements in our building, such as roof, beam, column, walls. They are all structural elements. And also, there are windows, doors, and they are assigned a little bit conceptual object named opening. And that opening can be assigned on a wall, not ceiling or floor or column, okay? That is the opening object. So in this relationship, we can figure out how a building can be composed of those structural and spatial elements. So based upon this approach, we can generate some more things, some more geometry, more information, and so on. That is information-based approach we need to take care of. So far, if you use some geometry-oriented approaches, even if it's 2D or even if it's 3D, it doesn't matter. Anyway, it's a shape, okay? Not a set of information. In a CAD model that is rectangle shape, which has office label, specific room label, with a bunch of dummy geometry. Dummy geometry here means just lines, surfaces, box cubes, polygons, and so on. They are just dummy geometry. But actually in information modeling approach that I show you, so-called BIM approach, in a BIM model, that is space object, not just a shape, okay? In that approach, space object contains information. What kind of information? ID, name, zone name, number, floor, topology. Topology means connections. This computer understands this space connected to this corridor and that space, which means that space, from that space, people can go anywhere, something like that, okay? 3D geometry data, that is also very important. But in CAD system, in 3D, 2D CAD system, geometry is almost everything. But in this approach that I showed you before, building design approach, geometric data is just a subset of that information, one part of that information. This is my point here, okay? Okay, if we have that kind of information, that kind of approach, advanced approaches and building information modeling, why CAD and graphics? Especially why 3D computer graphics? Why we are in this classroom? For what? Simply because you are second year student. Next year we're going to deal with some BIM or some more advanced things. But for enhancing your design visualization skills, we're going to deal with geometry-based approaches again, okay? Secondly, for moving forward to advanced design computing issues such as BIM for next year, okay? So I told you we have to know kind of brief history in terms of design computation, and you should understand where we are and what's the topic for this class, for this semester. That is why I show you this one again. When we believe geometric drafting, plans, elevations, sections, perspectives are design, building design, at that time, geometric drafting in 2D was enough to represent design. So, history of computer-aided design. Computer-aided design simply means CAD, okay? History of CAD is a history of understanding what is design. 2,000 years ago, Vitruvius, okay? Vitruvius believed that designs are perspective, plans, elevations in 2D by hand drawing. But using CAD, using AutoCAD, the same work, but done by computers. Looking different, but essentially they are totally same, okay? One by hand, one by computer. So at that time, 2D draftings are designed. But 3D surface-based model. Surface-based model means some series of polygons, and their combinations gonna generate 3D object. And that 3D object supposed to be design. When we believed that is the design, we developed surface-based 3D modeling software such as representatively SketchUp. You know SketchUp. You know how to use SketchUp, okay? But actually, our building design, we need some solid object. Solid object, which means not surface-based model. Something filled with that geometry so that you can make some operation, Boolean operation, and so on. Actually, we're not going to deal with this part, even this part, parametric modeling, and the most advanced one, building information modeling. The design is the integrated representation of all composition, analytical, and fabrication representation of the product. Geometry is just one part of the model, one part of the design. Product data modeling, so-called building information modeling. Its abbreviation BIM, BIM, okay? That is the most advanced one. Where we are here, okay? In terms of design history, probably a couple of 100 years ago. In terms of computing history, 20, 30 years ago, okay? We are not in contemporary, cutting edge, or the most advanced one. But you have to know where we are, okay, in this semester, in this classroom. We are focusing on surface-based modeling and surface-based visualization, especially rendering, photorealistic rendering using 3D Max, and some series of renderings. In other words, animation. That is the topic for this semester. Okay, here I list up the rendering work 1.5 years ago done by you guys, okay? When you were freshmen, you have been experienced V-Ray on top of SketchUp. So for the final project, you generated those images. Some of you, okay? And this one is GC Museum example. GC Museum designed by Daniel Libeskind and actually constructed. And some of you picked up this topic and visualized them in this way. And Sleepbox example rendered by V-Ray in SketchUp, and some different visualization style. X-ray mode in SketchUp, and some gray colored rendering using SketchUp and V-Ray. You're already well known to design visualization, especially using AutoCAD or SketchUp and V-Ray. In this semester, it's 3D Max design-based class for advanced visualization and representation for your design, okay? That's the topic of this class, this semester. What you have to learn are here. I showed you this one last week. Some fundamentals of computer science and engineering theory, hardware, network, internet, so that we can access the computer here, the shared folder and lecture files, accessing lecture folder and submit your file. You don't need to email me or using cloud servers. Just directly submit your files in this computer under your name folder, what we did in my class last year. Some of you are not knowledgeable to access this kind of network or internet or some Windows system. But anyway, we're going to deal with that part as one of the lab exercise issues. Secondly, we have to know some more fundamentals of design computing theories, such as history of design computing, where we are, what is information modeling, what is geometric-based approaches, and so on. They are also very important as design computing majors. In other words, interior architecture design majors. This is the major topic. Computer software, specific application we have to handle. That's going to be 3D Max design, especially version 2015, okay? Also, we're going to use Mental Ray, V-Ray, Photoshop, or some more tools for animation making or something else. A lot, even more things about design computing. We will take a look at some more things, more issues, okay? Let's take a look at, again, what you are. Okay, just a second. Let's get back to the slide material. So you experienced this kind of 3D visualization especially using SketchUp and V-Ray. You know how to visualize your design in a certain point. So photorealistic rendering or that kind of design visualization should be photorealistic or something realistic. What are the important issues we have to take care of in designing, especially using computers? So let me bring this one again. You have your own idea, okay? Your design concept, your idea. That's going to be only seen by you. No one can see it. You have to express by some hand drawing, expression, oral presentation, and so on. So that is why we need to make some design presentation. We have to plan, elevation, section, drawings should be prepared. So this process is kind of repetitive. That is why we need to make some computational model. At that time, last year, that was SketchUp model, okay? So we can do some digital design presentation using that SketchUp model. We can extract plans, extract 3D perspectives, sketch some pictures, some animations, anything else from that SketchUp model. So there is one computational model, one source, and multi-use. That's what we have done when you are learning that kind of design software. So we need more information. I told you today, information-based approach. What kind of information? That is building information, okay? So we are dealing with computational model. So we are handling building information and modeling. That's building information modeling, okay? So that is one of the advanced CAD systems in terms of CAD history that I show you today and last week. But our focus is on visualization, 3D visualization. Okay, here is your computational model. And it has its own mini world, its own universe, your universe of this course, so-called UOD. Your UOD is very important when you are making, modeling, designing something using computers. We're going to deal with this one again in lab exercise as a review. But actually there is actual real object for your design. Even if it's not realized, the most important thing is not just visualization, semantic integrity. Are they semantically same? That's the question. Between your model, your computer file, and real object. That's the top priority issue. So let's briefly talk about semantics in CAD systems. Is your CAD model photorealistic? Of course, simple comparison between two renderings. This one is stroke line-based drawing with shadow casting, and this is kind of photorealistic. So this one, of course, looking realistic, but that is just one snippet of this one. Does it have semantic integrity? That's the top priority. Photorealistic visualization is not always the solution. I mean, you don't need to stick to photorealistic rendering. Architecturally effective visualization is the matter. That's what I told you always. So sometimes line-based drawing, sometimes wireframe, sometimes just color shaded, sometimes very photorealistic. Okay? In terms of semantic integrity between your actual design object in real world and your computational model, your conceptual files, conceptual models, okay? That is very important, making semantic integrity. Let's take a look at some photorealistic rendering things using nowadays computing technologies, computing skills. This model, very famous design, Church of Light, done by Ando Tadao. You can download this model from 3D Warehouse freely and simply put some lighting objects in a couple of minutes and you can render it using V-Ray. In our classroom last year, one of you generated this one in probably 10 minutes, something like that. Another example done by SketchUp and V-Ray, looking photorealistic, okay, using common computer graphics tools. Another example, taking pictures using smartphone and make some objects. One object making some translucent option and some reflective effect on the surface, that red box cube, and try to render it using some top ceiling light system. And then you can generate this kind of rendering easily, quickly. This one done by 3D Max. In 3D Max, there is some primitive element making this one and some cylindric shape looking like a cup, and put some lighting objects and just click render button, and then you can generate this one in a couple of minutes, 3 minutes, okay, from nothing. You can make this kind of visualization in 3 minutes. How about this one? This one actually done by SketchUp and V-Ray, download from vray.com website. Another example, another computer graphics done by SketchUp and V-Ray, okay? How about this? This is 3D Max. Let's take a look at the universe of this scene, this design. This one can be done in 5 minutes from nothing using 3D Max. Just 5 minutes work when you are using 3D Max. In this world, there was nothing. But firstly, place one single plane, large scale plane, okay? Just plane which has no thickness, just one single plane, and 3 sphere objects. They are all primitive. Just simply click sphere and place them 3, and 1 teapot. Teapot is one of the primitive objects in 3D Max. You don't need to model this one, okay? Just simply click teapot and make it. Just place it. And there are a bunch of well-defined Autodesk material, presets. Ceramic material, simply assign it, and chrome material, and wood floor material, which has its reflection. Chrome has a reflection, reflectivity, and this ceramic, gray colored ceramic, also has a reflection. And there are some more objects. Take a look at those 4 things. 3 lightings which have white color and 1 yellow colored lighting. So total 4 lighting objects on top of those objects. And just render it using default renderer mental ray in 3D Max. You can use V-Ray or scanline renderer, whatever. But for taking maximum advantages of given Autodesk material, probably we're going to use mental ray and V-Ray. Anyway, we're going to deal with some series of renderers when we are using 3D Max. Anyway, that is why you can create this kind of scene just in 5 minutes, okay? Last week, I showed you this one as an example of contemporary computer graphics. This is not a picture. This is IKEA catalog, which introduced their products, their furniture, their chair system, and some bookshelves and some cubicle system, all done by 3D Max. For this kitchen, this is one part of IKEA catalog, not picture, not photograph. For saving money, same furniture system, but different by region. Kitchen for Asia, kitchen for Northern America, kitchen for Europe. They use some different faucets, different material, different sink bowl system, and so on. If they take pictures using actual hardware of their products, the cost for doing that much expensive than making it in computer graphics way. So that is why they use computer graphics. Here, using 3D Max, he just rendered this kind of images using that model, okay? This is contemporary technique, skills you can learn for visualization, okay? Nowadays, we have very, very advanced 3D modeler, 3D Max. Actually, current version is 2015, and 6 months from now, 3D Max 2016 gonna be released next spring, okay? Anyway, we're gonna use 2015 version, and we will use V-Ray too. Today, we're gonna install 3D Max in the lab exercise hours. Next week, we're gonna install V-Ray. And this is default renderer of 3D Max 2015, NVIDIA Mental Ray. We're gonna use that for using a bunch of presets, Autodesk material, and Photoshop for making your visualization better, okay? So, for design visualization, we are in the process of design computing. Our goal is design anyway. There is specific human creativity area. You have to create from nothing using your actual creativity. And you have to author your design, develop your design, visualize and analyze your design using entirely computational process, so-called computational processing. The process for design from your creation, from your creativity, from your human brain, entire process is so-called design computing, human creativity for design using bunch of computing technologies, okay? One of the technologies going to be 3D Max, Mental Ray, NVIDIA Mental Ray, and V-Ray, and Photoshop, and some animation making software for this semester, for your final project, okay? We are dealing with design computing, not 3D Max. That's my point here. Especially focusing on visualization, okay? 3D visualization, that's our topic. So we're gonna move to the lab exercise. But before lab exercise, I would like to bring your attention again about some design mode and design visualization and fundamental thing about rendering. Here I bring this slide again, design mode. Theoretically, we have 3 design modes. First one, mode of thought, the design still in your brain. Second one, mode of expression. Design is visualized, realized in front of your sketchbook or your computer screen, whatever. And finally, it's going to be realized in real world, okay? So the first thing, mode of thought, design is a plan. Design is an abstraction which generates ideas and concepts, okay? Still concept level, that is mode of thought. Second one is mode of expression, a way of making visual equivalence between your design, something in your brain, and something you created by using computers. Exploiting a medium's unique quality to maximize meaning. What is unique quality? Unique quality of V-Ray, unique quality of mental ray, and 3D Max, okay? 3D Max design, that is design medium. To maximize your meaning of design, meaning of concept, and then finalize it in actual real world. But we're going to deal with mode of expression. We're not going to take care of your design idea, design concepts a lot. Of course, you need to prepare some ideas for doing in our classroom for the final, but not always. We are not in design studio class so far. Next year, we're going to have digital design class, which requires some mode of thought. But in this class, we are not doing some design studio. You can do that in your design studio class. And we will handle some mode of expression issues, especially the medium, 3D Max designs, unique quality. So far, we design by hand, several thousands of years. But since we have invented computers around 40, 30 years, we now use computing. So design by computing. So our design media is not pencil, not something like hand drawing objects. We are using computers, computer software, hardware plus software, okay? So we need to take maximum advantages of IT, hardware, mobile devices, Google systems, cloud computing, 3D Max, network-based access, downloaded given geometry, existing files, existing models to design your objects, okay? We're gonna deal with not just how to use 3D Max. You need to know some more things about computing, IT issues, okay? So let's briefly review 3D visualization by computers, especially focusing on rendering. Actually, in 3D graphics, we can categorize two major things. First thing is modeling. Second one is rendering. What is modeling? The term modeling in our classroom today, actually not today, entire this semester, that's going to be geometric modeling, okay? I show you geometry-based approach today, not information-based approach, not building object-oriented approaches. We are still in geometry-based approach. That is why you need to know vertices, edges, polygons in 3D Max. We're going to have some editable poly, and you're going to learn how to control that polygons so that you can create any shapes you want to create, okay? That's modeling part. Today, let's review rendering first. And in our classroom, we're going to take rendering part first and then move on to geometric modeling, because modeling is kind of time-consuming task, very modeling something, sometimes very complicated, very not easy to learn. But anyway, I believe it's just a matter of time. You can learn, you can make anything else. So even if it takes a lot of time, you have to do. That's the issue and topic, intrinsic issues of modeling. But for rendering, there are a bunch of advanced techniques newly introduced renderers and techniques there are. So we will take care of rendering issues first and then move on to geometric modeling and combine them for advanced modeling and advanced visualization. Let's take a look at rendering first, because most of you already learned V-Ray based rendering on top of SketchUp. So today's lab exercise also tackled something else. So rendering basics in one single page. It's all about lights, okay? I displayed 5 different types of rendering. Take a look at the first one. Is this a rendering? Is this rendering? Of course, yes. That is line drawing, stroke line based rendering, okay? Without any shadow casting, any texture, any colors. That is just line based drawing. Sometimes it's very effective and architecturally effective. So you don't need to make everything photorealistic. That's what I mentioned today. That's what I put emphasis on today's lecture. You don't need to make all the rendering, all the visualizations in photorealistic. I don't like it because sometimes that kind of line drawing is enough, much effective. Anyway, that's the first stage of rendering. Secondly, we can put colors, no shadow casting. Third one, which has some shadow casting and some different diffuse effect. The first one, texture map, image-based texture assigned. The last one, which has a reflection and some more material diffuse options. Sometimes you are doing some V-Ray on SketchUp. Sometimes you're going to use Rhino. Sometimes you will use Revit or some other tools. And this classroom, you're going to use 3D Max. Totally different applications, but background theory, fundamental techniques are totally same. Here I list up the major things. 3 different categories. First one, lighting source. Second one, target objects. Third one, camera. Under lighting source, there are direct illumination, indirect illumination, and environment. For example, there is sunlight, okay? In V-Ray sun is there. In mental ray, there is MR sunlight system, daylight system. They are direct illumination, which has that kind of shadow casting. Indirect illumination, something like those ceiling downlight, lighting bulbs, lighting objects, and so on. Thanks to that lighting source, we can see object, okay? Of course, they are supposed to be target objects, your design objects. Sometimes it's going to be ceiling object, or roof, or windows, walls, furniture, and design objects, and so on. Target objects have diffuse, reflection, refraction, caustics, and so on. Under diffuse, intensity, texture map, shadow casting, ambient occlusion, and so on. The term described here were also found in mental ray, 3D Max. The same as you can see in V-Ray in SketchUp. Also there is reflection, refraction, and so on. They are all in the same way or similar way in mental ray, 3D Max, but totally different user interface. User interface are looking very different, but if you understand what is design, what is diffuse, what is reflection, how to control diffuse intensity, how to assign texture map in diffuse or even reflection, you can do the same as other renderers, mental ray, 3D Max, it doesn't matter, okay? That is why I described this one again. Global illumination, ray tracing, they gonna make your rendering scene photorealistic. When you are designing and rendering using V-Ray on SketchUp, you can generate this kind of images without doing any further tweaks or controls of your software. They are all default in 3D Max, Mental Ray, V-Ray. We can take maximum advantages of this kind of advanced things, okay? You don't need to take care of detailed things. But you have to know, you have to understand what is caustics, why this area is brighter than other area, something like this, okay? Because of caustics, this is translucent. Because of this lighting source, some lighting source gonna be focused and reflected like that way. Because of this geometry is sphere, okay? That is caustics. So at least we have to understand why this one can be enabled. And there is green colored wall like this. It's invisible here. But anyway, because of this green light wall, this area has some effect of that green color, okay? That is global illumination, ray traced, which makes your render scene photorealistic. We can take advantages of default renders function. On the rendering overview, this one single page shows you kind of terminology, taxonomy, when we are dealing with rendering. Lighting source, target object, and camera. Camera, in other words, observer. Your view. Something about camera, something about your target objects. There are diffuse, reflection, refraction, and so on. And some interaction between lighting source and objects and so on. That's what you have to know. For today's lab exercise course website, I described here. And let's move to the lab exercise. Installing 3D Max is one part of our lab exercise today.